Now I'm starting the code execution part of our project, which is exploratory data analysis of rainfall data in India. Here we can see the main steps of our project, which is exploratory data analysis process. First, we import the required libraries. Next, we load the rainfall dataset. Then we clean the data by handling missing values and errors. Finally, we analyze the rainfall patterns to understand trends and variations. Slide shows the libraries used in our project. We import pandas for handling and analyzing the rainfall data and matplotlib for visualizing the data in graph format. These two libraries help us perform data analysis and create clear visual representations. Slide shows how we create a sample dataset for our project. We define the data with two columns, year and annual rainfall in millimeters. The dataset contains rainfall values from 2018 to 2022. Finally, we convert this data into a pandas data frame so that it can be easily analyzed and visualized. Slide shows the summary statistics of our rainfall dataset. Using the describe function in pandas, we calculate important values like count, mean, standard deviation, minimum, maximum. These statistics help us understand the overall distribution and variation of the rainfall data. This slide shows the visualization of our rainfall data using a line graph. The x-axis represents the years and the y-axis represents annual rainfall in millimeters. The graph clearly shows how rainfall increases and decreases over time, helping us understanding the overall trend in a simple and visual way. We saw some steps of the idea. Then here I am importing all the required libraries such as pandas, numpy, seaborn for data handling and visualization. I am also importing machine learning models from sklearn, XGBoost for model building and evaluation. I am loading the dataset using pandas read CSV function. I am checking for missing values in the dataset using the isNull function. This helps us understand which columns contain null values so we can handle them properly during the data cleaning process. Here I am initializing different machine learning models like XGBoost, Random Forest, SVM. Then I train the models using the training data, making predictions and finally compare the accuracy scores to find the best performing model. After loading the dataset, I am displaying the first 5 rows using the head function. This helps us understand the structure of the data, including the columns and sample values before starting further analysis. Here I am using the describe function to get the descriptive statistics of the dataset. It shows the count, mean, standard deviation, minimum and maximum values, which helps us understand the overall distribution of the data. Dataset download and loading. The rainfall dataset is downloaded from Kaggle using the Kaggle API. Then the dataset contains rainfall data for various Indian states such as Bombay, Bangalore, Nagpur, Tamil Nadu, Kerala, Goa, Haryana, Delhi, Rajasthan, and etc. And rainfall data from year 2004 to 5 up to 2021 to 2022. Now we can see the graphical analysis is performed to study rainfall trends like heat maps and line graphs to understand the variations. In the final step, the system displays the prediction results for today's weather. If the model detects a high probability of rainfall, it shows chances of rain today. If the probability is low, it displays no. This is our agri rainfall prediction system called Krishi Varsha. In this module, farmers enter important weather details like temperature, humidity, wind speed, pressure, and rainfall data in the input form. Based on these parameters, the system analyzes the data and predicts the probability of rainfall. If there is a high chance of rain, the system suggests farmer to pass irrigation and fertilizer usage to avoid loss. Finally, all project files and reports are organized and sorted properly for documentation and future. Here, the model predicts the chances of rain for today. If the output shows rain, it indicates a high probability of rainfall. If it shows no rain, it means the weather is likely clear and suitable for outdoor activities. Conclusion: our exploratory data analysis of rainfall data in India helped us understand rainfall patterns, trends, and variations over time. By using statistical measures and visualizations, we gain meaningful insights that can support better planning and future climate relation decisions.